Hello, boys and girls. I am a middle school math Sith Lord. It's okay. Don't be frightened. It's a math party. It's a party. It's a party. We're going to do some math. Woo! Welcome. How have you all been? I certainly missed it. What happened to the other side of my face? Oh dear. Oh, there it is. Okay. All right, guys. Welcome back. We're going to do two videos on volume. The first one is going to be on prisms. A prism can be a triangular prism as such, or there's another type. Well, actually, there's plenty of types, but only two we've really dealt with this year. Then there's this guy. That would be a rectangular prism, even though it looks like a square, really. So you're going to end up with a shape and the same shape at the other end. And the shape that's the same on both sides, whether it's the triangular prism or the rectangular prism, notice the triangle here and here. This difference between the two shapes, that's the height. That would be the h. So this is a three-dimensional object. Okay, we have base on the bottom of this triangle. You can't quite see the bottom of it. And then you have the height, base times height. That's the capital B of the prism shape. Okay, and then this is the height of the shape, the whole 3D shape. Okay, so don't confuse that. We have the little b times the little h to get the big B base, the area of the base, or some people call the base the face. I mean, they're all faces when you spin them, but nonetheless. So this base has height. Now picture if we stood it up and down. Now this is not a rectangular prism, but if it was, let me get it in the same direction. There we go. If it was, and I stood it up, this is the height. And if you could picture if the top and the bottom were the same, okay? All right. Hey, you know, that kind of looks cool. Let's have a drink. All right. So, and then when you go to, let me just make one other point about that. The yellow is the base, the capital B big base of this 3D shape. So you have the length times width of this, or you could call it base times height. But then you have height of the whole, how do I make my, it's kind of hard to see how to make my finger go. So that's the length, the height of that figure. Do we understand? Do we understand? All right. So we're going to look at some IXL problems to practice implementing that formula. And I will show, first of all, I don't know how many people out there are afraid of heights. I know that sometimes life can be scary when you're at the top, like these guys. I'll catch you. I'll catch you. Pretty cool, huh? And there's tons of pictures like that. You guys can watch the coolest videos of a lot of these things, but look at that. That's from up on top of an antenna looking downwards. You can see all the buildings. Look down here in the corner. These are boats. Where's my finger? Down here. These are boats, okay? And you can see, where's my finger? Little dinky cars. Little dinky cars, and there's highways, and you can see cars. Man, that's freaky scary. All right, what else we got here? What if before there were buildings, there were, whoa, people who climb mountainsides and cliffs? Pretty crazy. That's more buildings. People like to get up there and take pictures. Kids, I advise, don't do it. But anyways, I would prefer just to see the drone pictures or helicopter pictures. Pretty cool. But the person's leg does give you a perspective of how far down it is. What else do we got here? Just got a few. Look at this guy. Look at this crazy guy. Now, you can see a car down here. Where's my finger? Look at just above my shoulder. There's a car and some little mini trees. Okay, building. This guy's on top of a crane, standing, taking a picture. I wouldn't do it, but I like the view from, because I'm afraid of heights. Believe it or not, as a tall person, I've always been afraid of heights. And I've been pretty high a number of times. Up. Let's see here, in planes, and I don't like to fly at all. Tall buildings, it's crazy. I mean, I get like lightheaded and freak out. All right, check this one out. Who knows what that is? If I recall, that is the tallest waterfall in the world, but it's called Angel Falls in Venezuela. And that is a river down at the bottom, even though it just looks like a little squiggly line. That's the waterfall. Goes all the way down. Okay. Really awesome. Love it. Here's somewhere in America. Whoa. You all know what that is, right? Golden Gate Bridge in San Francisco. Look at that. That's up on top of one of the towers, I don't know what you call them, where the suspension cables run across, one on each side. Wow. And then here's a walk bridge. Ooh, hold on, boys and girls. Over between two mountainsides, I guess, or whatever. Over the top of a river gorge. Crazy. Crazy. What was the one I wanted to do? This one right here. Oh, where's the clouds? I'm missing a picture. Did I skip it? Oh no. My favorite picture seems to be gone. I'll have to use it next time, boys and girls. Nope, here we go, here we go. Where'd that come from? This isn't the one I'm looking for, but it is a good one. Let me come in here real close. What about people who jump out of planes? Like this guy. That is so awesome. Woo! So I guess what I have to do here is... Oh, I found it, guys. I found it. Give me 1 second. This will be our last one. I had a really cool picture I wanted to share. Is this it? Oh, yes. Look at that. That is a beautiful sight there. Pretty clouds. There was obviously, this is, I believe, Dubai, and that's a pretty famous view. The water and the boats parked there from up above the Khalifa, currently world's tallest building, I believe, as featured in Mission Impossible, one of them. 1, 2, 3, 4, 5, 6, or 7. I don't know which one. All right, pretty cool, huh? All right, so let's get to the math, guys. I'm going to go back to since we're doing prisms, I'm going to pull up my prism, and I apologize for some of I'm trying to move my mouse around and find what I'm looking for. Okay, we're going to go to screen share, and we are going to, let's see, window, there it is. I'm just going to be looking here at iExcel. It's lesson AA8 Volume of Cubes and Rectangular Prisms. But this is word problems. But no worries, and I'm actually on the wrong, that's the last one we're going to do. There's just four levels, okay? I'm going to pull up text boxes and remind you of the formula, which will always be on your reference sheet and your formula sheet you get for any major tests, okay? Let's go with the color blue, and here's text box. So first of all, one of the things I always told you about volume, a line is one dimensional, okay? So remember, I'd stand in the room, I'd say from me to the door, that's a straight line, that's one dimensional. So it would be, that's not a minus sign. I was going to change it, but I don't know what else to put, okay? It doesn't say line minus one dimension. But it's the answer would be measured in units of like feet, okay? But then if I do the floor, that's two-dimensional, length times width. So you would also have however many feet times however many feet. I'm not sure how this recording is coming out. I think it's just my IXL screen, hopefully, so it's enlarged and you can see it well. Anyway, so 10 feet times 10 feet, let's say, that would be feet to the second power. Feet times feet is feet squared, okay? So that would be your unit when you're done. And then lastly, if I do a cube or a prism or whatever, that's going to be a three-dimensional shape, okay? So it's going to be 2 feet times 3 feet times 4 feet, if that were the measurements of the length times the width times the height, or the capital B, the area of the base times the height, either way. That's going to give you feet times feet times feet, or feet cubed, or to the third power, okay? So area is length times width, okay? Or base times height, okay? And when we do volume, a lot of people have always taught that as length times width times height. Okay, that will work for rectangular prisms and cubes, but when you get to triangular prisms and other shapes, you could have, we haven't done them really, but hexagonal prisms, you can do any kind of pentagonal prisms, octagonal prisms. I can't remember if I said that one already. They call it B times H, but the capital B stands for the area of the base. So it's the length times the width, or the base times the height of the area of the base, okay? But when you're done, you still have to do times H when you're done, okay? So that's the reminder of how this works. So now I'm just gonna run through, oh, I thought I picked blue as a color. What the heck, guys? Let's go up here and switch it back to blue. And let's look at this word problem. So here we have a three-dimensional object. The grocery store needs a new freezer for popsicles and ice cream bars. Summer's coming. The owner finds a freezer that's 4 feet long by 2 feet wide by 3 feet tall. What is the volume of this freezer? So I go get my text box here. It's basically just going to be 4 times 2 times 3, okay? Now, I said a number of times in my class, I usually take the two biggest things times each other first, and at the end, I'll have the smallest number times what's left. So if I did the two biggest numbers, that would be 4 times 3 is 12, and 12 times 2. So I'm going to have 24 cubic feet. Oh, I got to get select. So there's not a whole lot more to this, guys. We're just going to do 3 more problems after this one. 24. Not select. I need to do mouse. I know you guys can't see my little toolbox there. 24 cubic feet, survey says. Yes, fantastic. Let's do level 2, which I guess I could have done the last problem, but already had one open. In this week's episode of the TV show Strange Science Fiction, Strange science fiction. Oh, sorry. I just, after saying strange science fiction, I felt like I had to do that. Let's go back to the problem. I apologize. All right. A metal cube arrives. Now, a cube is a square that's three-dimensional. So that means it's the same measurement on all sides. Government scientists measure the cube and find there's exactly 6 meters on all sides. What is the volume of the metal cube? Let me get my toolbox that you can't see and open a text box. So I'm going to have length times width times height. Okay, and they're telling me it's 6 on all sides. Oops. So we're going to end up with 6 times 6 is 36. And I have another 6 left, okay? 6 times 6 is 36, so I will have a 6, but then I will carry the 3 on top of the other 3. 6 times that 3 will be 18, plus the 3 I carried will get us to 21. So it's going to be 216 cubic meters, or meters to the 3rd power is what that means, y'all. Okay? Bam! Super duper. All right. I'm going to go to the next problem. Clear. Oops. No. Clear. Okay. As their service project, Leon and his classmates pick up trash from the beach. That's nice. The class fills a dumpster that is 2 meters tall. The dumpster's base has an area of 11 square meters. What is the volume of the dumpster? Now here's a situation where they're not giving you 3 measurements. That gets a little confusing for some, but again, remember, there's 2 ways you're thinking of these problems. Now I just went back to mouse. Let me go to text. So the original way when I was younger, they always called it length times width times height, okay? But I told you, and it's on our formula sheet, they go with B times H. And that big B stands for the area of the base. And if you see, it says the dumpster's base has an area of 11 square meters. Something times something, it equals 11. Maybe 1 times 11, that would work. So that is the capital B. That's already a length times a width situation, and it came out as 11. So it's going to be 11 times, and the dumpster's 2 meters tall. That's the height, okay? So we're going to have 22 cubic meters. I always have to go hit this mouse button again. 22. Hit his submit button right here, and great job, great job. You're great, Greg. You're such a great guy. Thank you for doing math and helping us out. Let's clear that. And let's go to the next and final level, the challenge level. So there's only 4 levels, guys. And I did this a number of times. The problems will be intermixed. Like you will have one like I just did on the first level, okay? I tried to put them in order to where they're progressing to a little bit more difficult, okay? Ms. Hampton keeps a rectangular recycling bin for used paper in her classroom. Okay, the area of the bottom of the bin. Okay, so they're giving you the big B, the base of the bottom, or the face of the shape on the both ends. It's 400 square inches, so 400 inches to the 2nd power. So maybe it was 20 times 20, which would equal 400. She said it's rectangular, so that would have been square. Paper completely fills the bin to a height of 17 inches. What is the volume of paper in the recycling bin? So let me come up here to text box. I should have done that while I was reading and talking, sorry. So again, length times width times height. But we are training ourselves in 6th and 7th grade to now learn it as big B times H, and the big B is the area of the base of the object. She's told us, or they've told us, Ms. Hampton's area of the bottom of her bin, the base is 400. So it's going to be 400 oops, times the height of 17. Okay. Now, I've said this a few times in class, guys, just so I don't have to do 2 rows of math, I would put 17 on top, put times 400. I think in class I called it the zero trick. I don't know. One of my teachers taught me this. So instead of doing 7 times everything and then a 0 and 1 times everything and then adding it together, you can just do it like this. I'll put my 2 zeros down here on the bottom. They just automatically do that. And then I just go 4 times 7 is 28. Carry the 2 on top of the 1. 4 times 1 is 4, plus the 2 I carried would be 6. So I end up with 6,800 cubic inches. Let us go here. Very good, sir. Very good, sir. 68 cubic inches, challenge level. All right, good job, guys. All right, so that's it for the volume of rectangular prisms, which did include cubes. And we're going to go on to volume 2. Go check it out, y'all. It's going to have pyramids. Let me stop the share. And just remember again, one more time, I'm going to show these 2 pictures. This is a triangular prism because it has a triangle at both ends and this end back here. Okay, and then we also have the rectangular prisms, which in this case, the example I had picked looks more like a square prism. You have a square back here at the back, and then you have a square up here at the front. Okay, either way. All right, thanks for watching this video, guys. God bless and protect you and your families. Love you, miss you, peace. Floating head, we're out. It's party time, math time. Get your homework done, guys. We'll see you on the next